Awesome. We are going to go ahead and get started here. This session will be recorded. Good morning/afternoon, everybody. Welcome to Sterling and VMware's Power Block session. I am Megan Moore, Sterling's Director of Strategic Programs. We know your time is valuable, so we want to say thank you for choosing to spend a portion of your day with Sterling and VMware. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with an industry best value on all of your client to cloud IT needs. As you can see from the slide, Sterling holds many VMware competencies, including 2 master services competencies and more coming soon. Next slide, please. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal, state, and local government contracts and support all industry verticals. Security is extremely important here at Sterling. We have a robust, secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases you will find at the end of the demo. And for questions during the demo, please put them in your Q&A feature at the bottom of your screen, and we will address them at the end. Now I will turn it over to Cloud Architect Billy Downing to explore new virtual machine service within Tanzu to support complete infrastructure as code.
Awesome. Thank you, Megan, for the introduction. I was having internet problems earlier. Just want to make sure that you can hear me okay and see my screen just right.
Yep, everything's great.
Okay, perfect. Thank you. So welcome, everyone. My name is Billy Downing, a cloud architect here at Sterling. And today we're going to go over some of the new features that came out with a recent release of vCenter and specifically vSphere with Tanzu. First, we're going to talk about Kubernetes, give an analogy just to level set, what we're trying to accomplish here and what goal Kubernetes is trying to solve in this context. Then we're going to talk about how is that Kubernetes Kubernetes environment realized in the vSphere with Tanzu portfolio. So what are the different components that are involved with that, and how does it actually interact with your existing vSphere deployment? Then we'll dive into what is this new namespace service, as well as the VM service, rather, the virtual machine service within Tanzu, how those two services can come together to provide a very self-sufficient and self-service portal, so to speak, for your consumers of your platform. And then we'll do a demonstration of what that actually looks like and how it can be realized in your environments today. So to start off, I'll give a quick Kubernetes analogy. And again, this is just to level set. So if you have any questions at the end about this, just go ahead and we can answer those at the end. So for starters, the analogy we're going to use here is that you're going to some sort of a banquet or some sort of a party that you need to bring gifts for several individual people. So you're at the store, you purchase, say, 5 gifts for 5 different people, and you get all of those gifts wrapped up in a single package. Okay, so you have all your gifts. However, if you go to the party with it as it is, you have to give all of your gifts at the same time. They can't be individually wrapped, so it'll be you won't have a unique experience for everyone who's getting the gifts. So the next step to that is you're going to go ahead and take those gifts out of that original package. You're going to gift wrap them individually. So then you can go there and kind of hand them out to all the different people that they're intended for. That way, each gift can be treated individually, and each gift can be handled in its own way and delivered whenever it's necessary, when the person's available. The problem now is that you have, 5 individual gifts, and now you're trying to manage how do you take care of all these, different boxes you have to carry around. And, that could be kind of cumbersome if you consider maybe you go to a bigger party the next week and you've got to bring 50 gifts. It's a little bit more of a difficult task, logistically speaking. So to solve that, you kind of go back a little bit to the start. You keep them all individually wrapped, but you put them in a much looser based platform, or maybe a large stack or something like that, maybe a large table that you place them on, some sort of an entity to kind of hold them all together but keep them independent. So now you've kind of your original intention was to give everyone their individual gifts. You kind of created more of an issue, more of a sprawl with individualizing all those gifts, and now you're going back and kind of creating a platform to support all those different gifts that now you can hand out individually and treat as needed. So how does this relate to Kubernetes? And the kind of flow of what this is, what I'm getting at here is if we think about that first iteration of having all of our gifts unwrapped in a single package, that's kind of the analogy of a monolithic application. So everything is tightly coupled together. And in this context, we could be talking about the processes within a virtual machine. We can be talking about the processes within, a bare metal server. But all those processes rely on one another and they're packaged within the same unit. So they have to all be treated exactly the same, even if those processes have individual reliabilities or individual dependencies. So, containers came along. Became a way to more efficiently break out those services into individual entities that you can then manage independently and treat them as such. So you can, develop in the appropriate language per process and things of that nature without having to do a monolithic repo. But that came with a sprawl of services. So now if you had an application that had 50 services and you break those all out into containers, now you have to wrangle 50 different containers. How do you network them together? How do you provide uniform storage, and how do you provide scheduling for all those containers across a myriad of different platforms or cluster of nodes? That's where Kubernetes comes into play. So Kubernetes is that higher level orchestration for lifecycle management of all of those containers. So Kubernetes provides that abstraction layer, or, in the analogy, that platform or big table to put all of your services on top of, and give all of them equal access to network services or storage services, or, even just to schedule them on the appropriate nodes based on the requirements that they have. So you kind of have a little bit of best of the both worlds. You kind of have a centralized control plane that can take care of your distributed application. So now you have a way to break out all of your application independently so they can be developed in the most efficient way or deployed in the most efficient way, while still maintaining some sort of semblance of control and orchestration over the platform as a whole. So that's where Kubernetes kind of brings us to today. And that's a lot of the process of application modernization that we talk about pretty often. And that a lot of that comes down to Kubernetes being that orchestration level, excuse me, Kubernetes being that orchestration layer that you can then abstract any sort of platform across. So whether or not it's on premises or it's in the cloud, Kubernetes can be that standard table that you can place all of your services on to orchestrate scheduling and compute and storage and everything that's required. So next, how is that realized in the VMware portfolio? So how is that realized in Tanzu specifically? So what I'm going to kind of lay out here are the different components that are commonly used in the most robust on-premises solution of vSphere with Tanzu. And that's going to be using something like VMware Cloud Foundation with Tanzu on VxRail Manager in this instance here. So the first layers we have our infrastructure orchestration on the left here. This is going to be your SCDC manager, your VxRail manager. That's going to handle the platform itself from a hardware perspective, as well as your software that's running the virtualization, all that good stuff. The next step here to realize this solution, we're going to have your commonly known vCenter. That's going to be the schedule of your virtualization instances, your ESXi hosts. We can use vSAN for our distributed storage, and we can use NSXT for our software-defined networking. So within this stack, all of these components are distributed and software-defined, so we have a robust environment that can be abstracted over several different kinds of physical infrastructure. So the next step is we're enabling Kubernetes on this. That's the whole point of this, is how do we get this platform to run Kubernetes or run vSphere pods or containers or whatever workload that we have thrown at us. So Tanzu is the realization of that enablement on top of vSphere in this instance. So what we'll be seeing is we're going to be deploying Kubernetes master nodes, which we'll see as supervisor control nodes. Those are going to be the control plane for Kubernetes. We're also going to turn all of our ESXi hosts into Kubernetes worker nodes by installing a ESXi proprietary kubelet that can communicate with Kubernetes and give us that Kubernetes API endpoint to deploy and schedule workloads on top of ESXi directly. Within that, we'll have the concept of namespaces for isolating out our different environments and workloads so that we can deploy our virtual machines, our vSphere pods, as well as our TKG clusters, all within a defined space that we've allocated the appropriate resources for. The final steps of this, and then a lot of this that I'm going over now is really just a review, and then we'll jump into the new additions to this. But when we talk about vSphere pods, the question always comes up: How can I run a Linux pod on a bare metal ESXi host if that host is not running Linux? The answer to that, the VMware solved, is developing their own container runtime called CRX. And essentially what that's doing is placing a Linux kernel shim in between the ESXi host and the container itself. So that's kind of the realization of running vSphere pods directly on bare metal. But we also have the availability of deploying TKG clusters or Tanzu Kubernetes clusters directly on our platform itself to have what are called guest clusters to then run native Linux pods on top of that. All of this will make a lot more sense once I jump into the UI and kind of show you around and show you how this is realized in the actual environment. But what I wanted to do here is just to level set what is the context that I'll be discussing today, and how does this fit into potentially to your environment as you see it, if you have a typical vSphere environment. What I'll add to this diagram is that vSphere with Tanzu does not require these different orchestration levels here. So it doesn't require NSXT, it doesn't require vSAN, it doesn't require VxRail or even SCC Manager. To go over the functions that I'm going to be discussing today, the VM service, deploying vSphere pods, deploying clusters, all you really need is vCenter and your ESXi hosts. And everything else can be taken care of within Tanzu itself. And use your secondary storage, whatever you have available today. So what's the value in what we just discussed? And then we'll discuss what the value is of what we just went over, and then we'll add on the value of the VM service and the namespace service. So what does vSphere with Tanzu provide you for your on-premises deployment today? Is that's going to give you a single platform for your current applications as well as your future applications. So all of your applications that exist today in virtual machines or monolithic applications, or however they're built out in today's standards, that you can keep on running those alongside this new development. So you can continue to run your virtual machines just as you would, and then you can enable Tanzu to add capability without having to replace how you're currently doing work today. So that's gives you a very easy way to slowly migrate into a modern application framework and slowly redevelop or redeploy your applications into that platform without disrupting what you're doing today. The other value is self-service Kubernetes. So this is going to relieve a lot of pressure off of your operations teams, and relieve them from having to learn an entirely new paradigm in Kubernetes and deploying and managing Kubernetes themselves. Rather, this is going to allow your developers or your application owners to interact directly with the platform, and this platform in this case being vSphere with Tanzu, to deploy their own Kubernetes clusters and their own applications, because they have the most knowledge of how those applications need to be deployed within Kubernetes. So it just makes sense to hand them the keys within guardrails to be able to do that. Lastly, we have operations and developer app owner cohesion. So because we're giving this our developers and application owners that self-service capability, we're able to more cohesively develop the platform to afford our developers that capability. So what I mean by that is, rather than having operations folks deploy rather through a ticket system and deploy virtual machines and then give access to the developers just on that that virtual machine level, we're giving them the keys to the kingdom to kind of justify their own use cases and deploy their own clusters as they see fit, so they can remain agile and focus on developing their applications or deploying their applications without having any roadblocks from the operations team specifically. The operations team can still set guardrails around what is actually allowed to be deployed and what can and cannot be used, but it still gives the developers and application owners that capability and freedom to develop with agility as they see fit. So that's kind of vSphere Tanzu in a nutshell. So now let's jump into what does this look like with these new features that we're adding. What we've talked about so far is being able to deploy Kubernetes and run containers on top of vSphere, right? That's what we've talked about so far, but there's another component to that. And that component is going to be, well, we're modernizing our applications, or we're starting to use this new Kubernetes platform to deploy our new applications. But what if there are some applications that just don't make sense to be deployed as a container? Many organizations that I've worked with would prefer not to have databases in a container, for example. They feel more comfortable, whether it's a comfort level or even a technical level. There are sometimes reasons that containers don't fit every single use case out there. And so what that means is that you now have a split in how you're managing infrastructure. You're managing your virtual machines in a different way than you're managing your containerized applications. And that can create a split in how systems are being controlled. So what the virtual machine service is attempting to do, and what it accomplishes, this is the alpha state of this service. So this is a new service to vSphere. So it is in alpha. So take that in consideration. But what that does is allows Kubernetes, that Kubernetes control plane that we discussed earlier, to then control your virtual machines as well as your containers and your guest clusters. So now what that means is we're converging the control plane using Kubernetes on top of vSphere, so that when we do eventually get our applications built out, we can have an application that is built partially in virtual machines and partially as containers and work harmoniously within the same namespace and have the exact same control plane API to interact with to manipulate that application. So if we're looking at this diagram here, we can be looking at it from the perspective of this is basically how are we going to be building these services, and how has this changed the paradigm of deploying virtual machines and treating them more like declarative services rather than imperative deployment of infrastructure. This goes along the same lines as what I mentioned earlier, where the operations team can now focus more on optimizing the platform and allow the application teams to deploy the resources that they actually require. Since at the end of the day, the application team is the one that really understands their own requirements. So what this means, if we're going left and right from the services down the bottom or the blocks on the bottom, we have a few new objects that we deployed in our Tanzu cluster, and we'll take a look at what those objects are and how they work. But just starting off, we have the actual VM service. So what is this VM service and how is it actually realized? So if you're familiar with Kubernetes and how Kubernetes controls objects and schedules them, everything is deployed using some sort of a control loop or some sort of a service that monitors the objects that are being actually built out there. So what it does is constantly cycle through to say, is this object created? Is this object created? If not, create it. If it is, okay, move on. So what VMware has done is developed a VM operator that is going to be that source or that control plane or that control loop rather to monitor the lifecycle of virtual machines as they're deployed onto Kubernetes. So rather than having to go through the classic mode of right clicking, create virtual machine, discover your base image, deploy the virtual machine, get an IP address, deploy a load balancer, and then hand that information to the developer. Now the developer can interact directly with the Kubernetes API using a standard Kubernetes manifest that they can grab, just via how they grab any other manifest documentation, and deploy their own virtual machines, their own load balancers, and their own security policies for those virtual machines. And that's all going to be using that VM operator, which is kind of what encompasses that VM service. So at the end of the day, virtual machines are now considered first-class objects within the Kubernetes environment or the Tanzu environment in this case. So how do we, say we can deploy a virtual machine, but how do we determine, the guardrails? How do we determine what the developers can deploy? Because we don't want to run into the situation where, we have developers that are consuming too many resources or deploying too many boxes or, using an image that isn't, or a base OS that isn't, verified or scrubbed. So we have different objects, to kind of facilitate those different capabilities. So we have, for example, a VM class. The VM class can be enabled per namespace, so you can limit what your developers can actually deploy from a size perspective. So the VM class is going to be an instance of the flavor of the virtual machine. We'll see what these look like in the UI, but essentially what this means is you can determine exactly how much RAM or how many CPUs can be deployed on a per VM basis, on a per namespace basis. The next is, how do I know what the developers are actually deploying from an operating system perspective? So we have VM images that we can allocate per namespace to determine exactly what images they can actually deploy or what operating systems they can deploy. So the intent here is that eventually you'll be able to create images or pull images from VMware that can be, obviously security scrubbed and everything that you would expect out of a verified image to deploy in your environment. Right now, since this service is in V1 Alpha, the only images available are CentOS Stream and Ubuntu. So we're going to be deploying some Ubuntu boxes a little bit later, but it is V1 Alpha. So I just want to make that clear that you can enable this today if you upgrade to the latest version of vSphere 7. However, there will be some limitations on supportability for what actual virtual machines are deploying today. So finally, so you have your Kubernetes is going to be managing virtual machines. You have the flavor that you can deploy, and you have the operating system. But then, how do you actually customize that, or how do you actually deploy the services on that VM that you require, or install the application that you require? So if you think about Kubernetes and how that's done, that's going to be using config maps. So Kubernetes relies on config maps to inject configuration into your applications. It's also a way to decouple the configuration from the actual workload that's being ran. So what that allows you to do is now using VM specifications, we can use that to separate the configuration of our application from the infrastructure of the application. And so what that means is that, for example, if I am deploying an Ubuntu image today and I need to deploy Nginx on that Ubuntu image, I can treat those things as independent objects. So I can deploy my Ubuntu image, associate that with my config map, and have that config map inject in the appropriate details to deploy Nginx version 6. Say 6 months down the road, I need to upgrade my operating system, but I don't need to upgrade Nginx. So what I can do is deploy the latest image with Ubuntu 20, and I can still associate it with that same config map to deploy the same version of Nginx. So I can treat each one of these entities individually and test them individually to ensure that they work. And at the end of the day, what that provides me from a developer and app owner perspective is the ability to use infrastructure as code via Kubernetes manifest to deploy the virtual machines that I require, the version I require, and then inject the configuration that is necessary for my applications to actually become up and running. And that all happens alongside any other workloads that I have to deploy, be it containers or other Kubernetes clusters. So we talked about is that VM service is now we're able to deploy virtual machines within our namespaces, right? But that begs the question, well, how do I get my namespace then? How do I start from square one? That's where the namespace service comes in. And so what the namespace service is actually allowing you to do is allowing the vSphere operator to provision the capability to anybody else to provision their own namespaces without even interacting with the vSphere UI at all. They'll be able to do this directly through the Kubernetes CLI using kube control. And what they'll be able to do is create their own namespaces that are bound by guardrails set by the operators. We'll take a look at what some of those guardrails are. But just to kind of, just to summarize that, you can set what storage classes they can use, how much storage they can use, how much RAM they're allowed to allocate, and how much CPU resources they're actually allowed to provision within that namespace. So what this allows you to do is, again, this common thing of relieving your operations team from the burden of assisting application team with deploying their infrastructure and allowing your operations engineers to focus on optimizing the platform and allow your application teams to focus on the infrastructure they require for their applications. If those two teams are the same, the same person or within the same team, then what it's still doing is converging that control plane for everything they're trying to accomplish. So right now we're converging everything on top of Kubernetes. So at the end of the day, whether you use the Kubernetes native way of deploying these resources or you use the vSphere way of deploying these resources, you're accomplishing the same goal. You're able to tailor how you deploy applications in this way based on your existing skill set, as well as your existing application frameworks. So kind of just an example of what a namespace is here. And in that context, we have on the left-hand side, perhaps a systems engineer or an application owner. They have a namespace that's allocated to them or that they've created. And within there, they're allowed to provision their own storage. They can deploy their own network. And we'll see how that interacts with NSXT in this example to deploy load balancers. They can deploy their vSphere pods if that's what their application requires. They can deploy Kubernetes clusters if that's what, if that's something that they would prefer to do, or they can deploy virtual machines independently. So really what this allows you to do is at the end of the day, you're giving your developers full control to be able to do their job as most efficiently as possible while relieving the burden from the operations team to let them focus on what their main goal is, and that is platform availability, platform efficiency, and platform security. So I wanted to review quickly kind of how does the value proposition then change from the perspective of, okay, so it's added these two new services. How does that change the original value that vSphere with Tanzu on premises is going to bring to my team? So I didn't really change the slide, but I added some of the phrases in here of some of those tools that are going to be and how they affect your actual deployment methodology. So for that first one, you still have that single platform for your current applications and your future applications. It's just now and on the roadmap to be, you'll be doing both of those operations using the same common API in Kubernetes. In this case, so to be a Tanzu version of Kubernetes. But at the end of the day, we no longer, or going forward, we will no longer have the separation of management from virtual machines and containers. We'll have all of that converge under a single control plane, and all of that will be housed within vSphere. The second bullet there is a self-service environment. So previously I had that as self-service Kubernetes, but now with the namespace service, it's not only you can deploy vSphere pods and Kubernetes clusters, now you can deploy namespaces, and within namespaces, you have a little more freedom with the VM service to go ahead and deploy other applications within that you require. And as I mentioned earlier, there's several different applications that you can make a strong argument that aren't appropriate for containers, and you don't want to abandon your existing way of backing up virtual machines, or you have maybe you have strong investments in backup solutions or different things like that, or disaster recovery solutions that are tailored around virtual machines. So now you can create a namespace and start deploying those applications, in the format that you're comfortable with, and be that virtual machines or pods or clusters. But at the end of the day, you're essentially through the namespace service able to deploy a platform for yourself to deploy whatever your workload is required. That final bullet there, I basically just added in there and provide app owners the ability to create infrastructure specific to their applications as they are the ones who have the best idea of what is needed. So it's kind of been going through this iteration the past, maybe decade or so, where previously applications had to be developed in a way that they were abstracted or independent from the infrastructure from which they would be deployed. And that was because there was never really a standard infrastructure platform to deploy applications. So the application kind of had to be independent and had to be modular in a way that it can consume load balancers from different entities. It can consume storage from different entities, and none of those things were actually tied together cohesively. They were stitched together by common protocols and things like that. So what we're doing now, and what Kubernetes is providing, is that common platform to provide those services. If we go back to that original analogy, Kubernetes is that common table that you can put all of your services on to allocate storage, network, and compute. Now applications can be developed in a way that the application can be aware of the infrastructure. If you deploy a Kubernetes application and that includes a service of type load balancer, well, then you would rely on Kubernetes to realize that load balancer. You wouldn't put that onus on deploying a load balancer to a separate team to deploy, an Avi or an F5 or whatever it is. You would put the onus on Kubernetes to interact with your underlying infrastructure to deploy that. So, having this shift in paradigm puts a lot more of that control of the application into the hands of those application owners and developers. And so giving them the capability to deploy their own namespace where they can then deploy their own load balancers, deploy their own virtual machines, pods, clusters, whatever they need. It just gives more cohesion to the different teams to allow them to focus more on what their actual mission goal is. Operations teams are typically focused on security of the infrastructure, availability of the infrastructure, and efficiency, whereas application owners and developers are focused on agility of their application, mobility of their application, security as well, efficiency, but that efficiency is at a different layer. So with that, just kind of want to go through all of that. I know I've been, I talk a little bit fast sometimes, trying to slow down, but kind of going over what this service is, this namespace service, this virtual machine service, how it integrates with Tanzu in an on-premises deployment type of environment. And now we'll go ahead and take a look at, what are all these different things look like in the actual UI? So how is this stuff realized, and how can it be relevant to your vSphere environment today? Okay. So what I have here is a pretty small environment. And so I like to use this environment just to show that, I've talked about a lot of infrastructure here, But at the end of the day, all of the stuff that I'll be showing today is running off of a vCenter, 2 hosts that are Blades and an FX2, and I'm using NSXT as well. I'm not using vSAN, I'm not using VCF in this particular case. It's just to show that you can have this capability on the platform that you have today. So what I have here is 2 hosts. Then we have this namespace tab here. Within this namespace tab, we have a few separate namespaces we'll talk about in a bit, but we can also see I have a separate control plane here. So just like this virtual vCenter is controlling my ESXi hosts and scheduling my virtual machines, these supervisor control plane nodes are acting as the control plane for Kubernetes to deploy virtual machines using the VM service, as well as containers and clusters into my namespaces, which are then again ran on top of my physical bare metal as well. So if I take a look at these, this cluster from a Kubernetes perspective, and I go over here, I go to monitor and I take a look at what is this, how is this cluster performing? I can see just a general idea of this is a Kubernetes cluster that is built on top of vSphere. So I'm running version 1.19. We can see that I have 2 actual worker nodes, and then I have 3 control plane nodes. And these are going to be my virtual machines, the supervisor control plane here. You can see my nodes are healthy. And I can see what the IP address is to interact with my actual control plane is. So within there, I can see, I have my namespaces. So I've just created 2 right off the bat. I've created a developer-owned 01. I've given access to a user account that's just called developer in this case. And this is all from the operations hat. So when I'm looking at the vSphere UI, I'm looking at it from the vSphere admin's perspective. And what that is doing is kind of bringing home that idea that you can separate these roles so that each one can focus on what is most important to their specific job for the day. So what I'm doing here is I'm giving access to this. I'm assigning a storage policy. And within that, I can also assign limits on capacity and usage from a CPU, memory, and storage perspective. Then what I'm doing is deploying a content library to give them access to the images that would be required to deploy guest clusters. And then here's where we see that VM service. So when I'm talking about this VM service, we talked about the VM classes or the different flavors that we can allocate to our namespaces. So if I go here, I can say for this particular namespace, I want this developer to have access to these flavors of virtual machines. So I don't want them to be able to guarantee sizes. I want them to have all of the best effort sizes of virtual machines available to them, so they can create their virtual machine based on their application requirement without having to ask for, ask the operations team to do it for them. We can also go here and manage the content library, and the content library is going to be the source where the operating system or the actual OVF or image that's going to be deployed, it will be located. So from here is where we would place, so I have this associated with a content library that has, an Ubuntu image in there, and it has the VMware CentOS stream image in there as well. If I go to the service, I can just see that this is just a summary of what I have available. I can create new content libraries. I can create new classes just to make sense of that. So that is kind of what from a namespace perspective, I have this namespace. And now that I've created this, I can go ahead and copy this link. I can send it to my developer. And then that developer will now have instructions on how to actually access this cluster not using vSphere, because perhaps that team doesn't use vSphere, they're not comfortable with it, they haven't touched it, or you don't want them to have to be touching a vCenter, but they are comfortable with Kubernetes. And then you just send them this link, and it'll explain to them exactly how to access what they've been allocated. So once they've given access to their namespace, they can start deploying workloads within that namespace. But they also might want to deploy subsequent namespaces for other tests they want to do to create isolated environments. So if we go back over here to this cluster, we could take a look at configure, come down here to our namespaces and our general configuration. We can see the namespace service. So what I've done is I've activated that service, and I've set up a template that is limiting what the developer account can actually provision if they create a new namespace. So I'm limiting this account to deploy a namespace that using the TKG policy storage policy for where the physical devices are actually going to be stored. I can limit the amount of storage they use, amount of memory, and amount of CPU they can actually utilize. So what that does, if I come and I look at this developer-owned 2, this one was deployed by the developer. So you can see here that the owner is the developer. And we can see that it actually inherited those guardrails that we just saw within that namespace. So we can see that it has a 200 gig limit, 32 gig limit for RAM, and 32 gigahertz limit for CPU. So this whole time we've been looking at this from the perspective of the operator, or the perspective of the vSphere admin. So let's take a look at what does this look like when you're the operation, or you're the application owner, or you're the developer who's trying to work with this system as a platform. So typically that'll be done through the CLI. So this is where that infrastructure as code idea comes into play. So what I'm going to do first is I'm going to log into this cluster using kubectl. It's a vSphere plugin that is in that link that we looked at earlier. I'll log in as the developer account. I'll put in the right password. And we can see the context that I have access to. So we can see these two contexts here. So when I log into this, I will just use let's first look at like how do I see this environment from the perspective of the developer. So I can see exactly what the operations team sees. I have 3 master nodes and I have 2 worker nodes, the actual E6i hosts themselves, for which I can use to deploy virtual machines or any sort of workload. So if we're looking at this addition of what the VM service is and what it's actually adding to the capability, if I look through the new objects that are created within this, so if I look through, if I go through the API resources and I look for the VM operator, I can see all these new objects that I'm able to interact with. I can see a VM object, I can see the images that I can view, the VM class binding, and VM service. So if I go through, and I'll go back over here and show that I do have a virtual machine deployed, which is managed by Kubernetes. And so I can take a look at what's the status of that virtual machine. I can see if I were to deploy another virtual machine, what images do I have available? So I can deploy, I have that CentOS stream, I have my Photon images and my Ubuntu. I can see, okay, what VM classes do I have available? So what sizes can I actually deploy this in? I can get that information all from here. And this is all the guardrails that are being placed by the operator for the developer to be able to deploy everything they need to know and to have all the information they need to deploy those resources. So I can take a look at VM services that I have deployed as well. So I have a load balancer deployed, and this will be realized in NSXT. And I can then see like what's the actual IP address that's being realized on that load balancer. So now I have my virtual machine deployed, I have my load balancer deployed, and I'm fronting that with an external IP address, all facilitated through NSXT and vSphere. But at this whole point, from the developer perspective, I never actually had to interact with vSphere itself. So what I'll do is I'm going to demonstrate so what does it look like? So if I were to start this from scratch, so say this environment, I already have a load balancer, I already have a virtual machine. What if I were to start from scratch and say I wanted to make a change to this virtual machine and I wanted to go ahead and test out some changes? So I want to do that in a separate namespace. So I'm going to use a different context. So I'm going to use that 02. If I go here, I notice I don't have any virtual machines and I don't have any VM services. But I do still have access to the VM image that I require. So I can still get access to this Ubuntu image. And if I look at some of the files that I have in here, so if we look at this from a perspective of infrastructure as code, I'm going to deploy a virtual machine, but I don't have to actually click anything, and I can edit that virtual machine strictly through text. So if I look at this dev app1 YAML file, I can see this is a normal, what you'd expect in a Kubernetes YAML file. So I have my API version, which is that VMware operator that we looked at earlier. My object type is virtual machine. I can see the name of that virtual machine, what namespace I want it to be deployed, and I can also set labels to it just as you would any Kubernetes object. I'm setting my network type to NSXT, so it's going to attach this automatically to an NSXT segment, and it's going to be provided an IP address through that. I'm using my class name to determine the size, the image that I want to have, and what the storage class is actually going to be utilized here. So say, okay, I want to test this virtual machine. So I'm going to go ahead and I'm going to deploy it. I don't need to ask for, resources. I don't have to ask the team to go ahead and help me, can you deploy me this box through a ticket and then have them send me back, the credentials for it. Just like that, I can go ahead and deploy that. And now you can see that virtual machine is actually being deployed. And this is all about the VM service and all that good stuff. But there's also that component of networking that kind of tags along with this. So if I quickly go over to look at NSXT, and what I'm going to do is take a look at specifically load balancing. So when I'm looking at load balancing, I can see here that I have a developer owned to load balancer that was deployed automatically with the creation of that namespace. But right now I have zero virtual servers. So there's actually no way to access my application directly. I can make the IP address routable, but in this instance, it's going to be behind something. So I want to set up a load balancer for this application as well. So it mimics my other one exactly. So I'm going to create another VM service. And just like my object in my virtual machine, my load balancer is going to be another, just a different type of object, but also written as a YAML file that I can then store in Git and version and all that good stuff. So to create a load balancer, all I have to do is deploy the object as I would expect. And then if I come back over here, I should see that object is now being realized. So now this object that I just deployed has an external IP address, and you can see that it's actually connecting to my virtual machine based on the tag that I had set up earlier. So it's going to connect to that virtual machine once it's fully created, because I have this as selecting the app test, which is the same label that I've given to my virtual machine. So the point of all this is that as a developer, now I have access to a namespace. I can deploy virtual machines. If I wanted to, say, okay, well, this application isn't going to be for a, it's not going to be a virtual machine. I want to deploy, a regular pod for this. I can go ahead and do that. I can still deploy a regular deployment, a regular Nginx container, or a pod in this case, and I can also deploy a pod in that. If I wanted to go ahead and deploy, maybe I wanted to test out advanced functionality, and I wanted to test out, I want to see what it's like to run this in a native Kubernetes cluster or a TKG cluster. So, but I don't want to mess with what I have going on here. So I need a new space to do that. I need a new environment to do that. So I'm going to create a namespace. I'm just going to call it test 01. And now we see I have a new namespace over here that I am the owner of. So now I have a new namespace. And again, from the developer's perspective, and I'm just going to log back in to pull that into my kube config. Oops. So now we see I have access to a new namespace. So, just like what I was saying before, I'm a developer. I want to go ahead and deploy some new stuff in there to test some new functionality. So I'll go ahead and jump over and use that context. And this time, I don't want to deploy a virtual machine. I don't even want to deploy a container. I want to deploy an entire cluster that I can use to test. So if I look through here, I have this, this other YAML file here. Again, just a YAML file written as code that I can check into a Git repository. And I can see here that this is actually a Kubernetes cluster. This is actually a Tanzu Kubernetes cluster with one worker node and one control plane node, similar as all of my other things. It's just a different object to be deployed. And again, just like everything else, all I have to do is interact with the same API I've been interacting with this whole time, the Kubernetes API, and deploy that object. So once I deploy that object, I should start seeing that being realized over here at any second. And so what I've kind of demonstrated over the course of all of this is the ability of the developer to have the keys to the kingdom with guardrails, of course, because, if we see this, if we take a look at this namespace I created, I do have limits set up. And you can now see my cluster is being deployed. So the point of all of this is really that we as platform operators from a vSphere perspective, vSphere and VMware in an on-premise environment needs to be agile and able to handle whatever workloads our developers are throwing at it. So what that means is that operators need to be able to focus on what's important to them and hand over the responsibilities to the application owners and the developers for the responsibilities that they have. So it allows both teams to work very harmoniously on the same exact platform while accomplishing individual goals. And this means that you can use the skill sets you have today, your vSphere admins, to deploy this platform to then facilitate your application owners to then deploy the application in the way that they see fit that works for their application specifically. Whether that means that they're deploying a separate Kubernetes cluster, whether that means they're deploying it all in vSphere pods, or they're still deploying it as virtual machines. The addition of the VM service the VM service as well as the namespace service affords them that ability to be agile and allow them to go through and be more efficient with how they're deploying applications. So just to finish that up, to summarize, I mean, this is just a solution overview and just kind of a summary slide of everything we've talked about so far. I know I've covered quite a bit, but I wanted to make sure that I set the context of what is vSphere with Tanzu and how we're discussing it for this specific webinar, that on-premises solution, and then how does it reveal itself to our developers and our application owners, and how can they best consume these resources that we have on premises to make it more like a cloud-like infrastructure. We want them to be able to have whatever tools that they need when they need them under the guardrails that we set, so we don't hinder innovation and agility within our deployments. We give the developers an easier way to upgrade applications, to manipulate applications, to deploy applications on infrastructure it's required, because again, they know the best requirements for their applications. They can most efficiently deploy that. So with that, if there are any questions in the chat or anything like that, we can talk through those now. But yeah, I appreciate everyone kind of hanging in there and sticking along.
Thanks, Billy. We do have one question here. How can you actually configure the VMs deployed using the service?
Yeah. So that's going to go back to the config maps that we talked about earlier, and that is a native Kubernetes object. And what that is going to resemble is if you ever deployed a common template and used a VM specification file, like an answer file to deploy, is it going to be added to this? Is it going to be deploying the service, whatever the case may be? It'll be similar to that. So in this case, for the images that VMware has released so far, that CentOS image and that Ubuntu image, you can use cloud init. And essentially what you would do is compile or consolidate that cloud init file. And the cloud init is, again, that step-by-step, what services are deployed. Once the VM comes up, it's the configuration applied to the virtual machine. So it's the step-by-step, install this service, update this service, set this IP, set this host name, install these SSH keys. Everything that you need to actually install the application can be done through cloud init, and then compiled into a config map and associated with your application itself. So it's, again, it's a way to decouple the configuration from the actual VM itself, much like you would in a native container world, where you would decouple the deployment configuration from the application itself so that you can interact with them independently, update them independently, and kind of go about it that way.
Great, thank you so much. That is all the questions we have for today. If for any questions following this demo, please reach out to these email aliases you see on the screen. We do record all of our sessions, and so this recording, as well as all of our previous demos, will be available on our website. So please check out sterling.com and hit on our proven performance page. Thanks again, and we will see you next week. Have a great day.